Okie doke. This is day 4 of Algebra 1 Polynomials. Okay, hi, Mr. K speaking. Hope everybody's doing okay, hanging in there, hanging tough. All right, it is 8:53 a.m. as you can see on my iPad. All right, so all enjoying, I don't know, hopefully you guys are getting some sort of routine here. Okay, I keep talking about the routine. It's important to have a routine. All right. It's important to, take time for yourself, stay on top of your studies, help your family any way you can. That being said, I'm going to stop ranting and let's express this as a trinomial. Okay? So, see this piece out in the back here. We'll get to this piece later, all right? Right now, we're just going to leave that piece alone, okay? What we are going to do is we're going to multiply these two things together. Okay, so 3x times x will give us 3x squared. 3x times 7 will give us 21x. Negative 4 times x will be minus 4x. And negative 4 times 7 is negative 28. Don't forget that negative 1/4 x squared. Okay, tag onto the end there. All right, now we're going to combine like terms. Okay, we also see this x squared and this x squared. We'll get to that part in just a moment here, okay? But I don't want to add those two pieces together right now because they're fractions, and I don't feel like adding the fractions here right now. All right, so let's get these easier ones together first. So it's 3x squared, okay? Positive 21x and a minus 4x will give us a positive 17x minus 28 and minus 1/4 x squared. Okay? Now, in order to express this in standard form, again, we need to go from our highest degree measure, to our lowest. Okay, in which we don't have that right now. I need to combine this term here and this term here. Okay, in order to do so, all right, we need to add these two fractions. So 3x squared minus 1/4 x squared. Okay, so what do they both have in common? We got that x squared. So we really just need to add the 3 and the 1/4. And so remember, when we're adding fractions, okay, you need to have a common denominator. So in order to get that, multiply the top and the bottom by 4. And 12 minus 1 will give me 11/4 x squared. Okay? So that's what we get when we add these two pieces together, when we combine like terms. Okay, so let me finish this problem off here. All right, so it's going to be 11/4 x squared plus 17x minus 28. Okay? Now it's expressed in standard form. Now, typically though, I don't know if they want this on the Regents or not, but we don't typically leave these with fractions in them. All right, so in order to get rid of a fraction, what we need to do is we need to get this 4 to cancel. So if we multiply the top, or multiply everything by 4, what happens is these 4's will cancel. Right, in this first one, we also have to multiply everything by 4. Okay, when you multiply everything by 4, right, and you get 11 x squared. All right, 17 times 4 17 times 4, 68x, and negative 28 times 4 is negative 112. Okay, not too sure what the Regents is going to ask for, but just to play it safe, all right, get rid of those fractions. Okay, we don't like fractions in there in our quadratics. Okay, so in order to get rid of that fraction, I had to multiply everything by 4. Gets those 4's to cancel in that first denominator, and everything else just gets multiplied by 4. So our answer to that is 11x squared plus 68x minus 112. Okay, so that's the answer to number 16. Number 17, okay, so the expression, all right, called an expression because we don't have an equal sign there. So the expression 49x squared minus 36 is equivalent to what? So again, we got one of these equivalent problems, all right? So what we're trying to find here is when factored, all right, which one of these things is equal to the same expression up here, okay? Now you could cheat. Like I said, you could just plug in a value for x squared, maybe 1, or you can plug it into your y equals, all right, and find which table of values matches up, all right? Or if you don't want to do it the chintzy way, we could factor this bad boy, all right? So anytime you see, well, first thing you want to look at is, can you take it out of GCF? All right, so we got 49 and 36. Now 49 is a very specific number, okay? It's a special number, so is 36, all right? We'll get to that part, but there's no common factors between 49 and 36, okay? So, that being said, all right, let's talk about 49 and 36. Also, we notice this is a binomial, and we see in the middle a subtraction sign. So I suspect that this might be a difference of two squares problem, okay? So if you can't take out a GCF, check to make sure that these two numbers, check to make sure whether or not they're your perfect squares, all right? And if you have a subtraction sign in the middle, then we know that this is a difference of two squares problem, okay? So here is our squares, all right? So 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and 256. Okay, and when I say perfect squares, I mean this is 2 times 2, this is 3 times 3, and so on and so forth. Okay, now we see these two numbers in here, 49 and 36. Okay, this is 6 times 6, and this is 7 times 7. All right, so this is some number squared. This is some number squared. We don't know what that number is, but it's being squared, right? That's what that 2 signifies, right? It's being multiplied by itself twice, and then we see a subtraction sign in the middle. So this is difference of two squares. All right, so we put an x on both sides. We split up the x. We put a plus and a minus, and then in front of the x will go a 7, and behind the plus and the minus will go a 6. And do we see that answer? We sure do. Okay, so that's number 17. Number 18, all right, write the expression 5x plus 4x squared times 2x plus 7, in parentheses, minus 6x squared minus 9x as a polynomial in standard form. Wow. Okay, so there's a lot to unpack there, all right? Now, I'm seeing a couple like terms here. Okay, so we're going to have to combine like terms. Also, we're going to have to multiply or distribute this 4x into that set of parentheses. And then we're probably going to have to combine like terms again. Okay, so let me get this out of the way here. There's some of these numbers here so they're not in the way. Okay. There we go. All right. So let's multiply that thing out there, all right? Before we start combining like terms, let's get all of our everything on the same level field. Okay, let's get everything multiplied out here. So 5x plus, all right? So 4x squared times 2x will give me 8x cubed. Okay, and 4x squared times 7 is a positive 28x squared. And then, oops, and minus 6x squared minus 9x. Okay, now we can combine like terms. Right? There's no more multiplication, right? Everything's just addition and subtraction. And now let's pick out our like terms here. So here's 5x and negative 9x. I also see this one by itself. And then those two will go together. All right. So when it says write it in standard form, again, we're going from highest degree measure to lowest. Okay, so the highest one we see here is that 8x cubed. All right. The next highest degree measure I see is an x squared, so 28x squared minus 6x squared will give me a positive 22x squared. And then a negative 9x and a positive 5x will give me a negative 4x. And so here's our expression, written in standard form, which is what they asked for. Okay. Let's look at number 19. I can fit it all on the page here. Come on. There we go. All right, so the area of a rectangle is represented by 3x squared minus 10x minus 8, which expression can also be used to represent the area of the same rectangle. All right, so it might be a little unclear in what this thing is asking here, okay? So let's just go back to what it means to find the area of a rectangle. So here is my rectangle, okay? In order to find the area of a rectangle, it's length times width. So area is equal to length times width. All right, here we just have an expression. All right, but if you notice, all of these are something being multiplied by something. All right, so what do we have here is we have factors. Okay, these are all factors of some larger expression. Okay, and let's think about this for a second. All right, what's happening here is all of these, all right, are being kind of treated like our length and our width. Okay, so one of these binomials represents the length, and the other one represents the width. So this is the length, the width, the length, the width, the length, and the width. Okay, now we don't know what x is, okay, but we can all agree that they're both some sort of number if given some value for x. Okay, they'd all represent some sort of number. So it's our job to figure out which one of these expressions, which one of these factors, all right, represents this larger expression. So really what we're trying to do here, guys, is all we're trying to do is factor this expression here. And once we factor it, factor the expression, okay, then those two factors represent our length and our width, okay? This is all that means. So the area of a rectangle is represented by this expression, all right? Which one of these expressions below can be used to represent the area of the same rectangle? So all we're trying to do is we're trying to factor this thing. Now, what's difficult about this one, okay, is we have a leading coefficient greater than 1. Okay, our leading coefficient, or our a value, is 3, which means we're going to have to use factor by grouping. All right. In order to do that, you're going to take your A value and your C value, and you're going to multiply those two numbers together. So when you multiply those two numbers, okay, we get 24. So what we want to look at is the factors of negative 24, because we have that negative sign there. Okay, so negative 24. All right, so negative 1 and 24, negative 2 and 12, negative 3 and 8, negative 4 and 6. Okay? Now, what we're looking for is which two set of numbers, okay, could we multiply together to get a negative 24, but then when we add together, we get a negative 12, or a negative 10, I'm sorry. Okay, so we're trying to figure out which two numbers multiplied together gives you a negative 24, and when added together, gives you a negative 10. Okay, so first let's just take a look at which one of these numbers can actually get us 10. Okay, so it'd be negative 4 and 6, and negative 2 and 12. And so we need a negative 10 though, but we need these things to multiply to be a negative number. So this one is out, and it has to be this one, but because we want the 10 to be negative, we want our larger number to be negative. Okay, which means we want negative 12, not negative 2. So now, in order to do factor by grouping, okay, we start right here. So we take our 3x, we bring it down, and then we just use these two numbers and we kind of split up that negative 10. So we're not going to really change the value of this middle number. We're just kind of splitting it up based off these two factors. So I'm going to go negative 2x, oh, I'm sorry, plus 2x minus 12x minus 8. Okay, so if you look, when we add these two middle numbers together, 2x and negative 12x, okay, we still get negative 10x. We didn't change the value of this number in the middle. All we did was just kind of split it up. And now we're going to do what we call factor by grouping. All right, so in this first piece, I'm going to take out, I'm going to try to take out what is a common factor between the 3x squared and the 2x. What can I take out of both pieces? What is one thing that both pieces have? And that would be an x. Okay, so if you take out an x, you're left with 3x plus 2. All right, now remember when we factor by grouping, all right, what we factor out of the second piece, all right, what we have left in parentheses should match with the parentheses, what's left in parentheses in the set of factors before. Okay, and anytime you see a negative number, there's a negative 12x, okay, you always want to take out a negative number. So in this case, it's going to be a negative something, all right, and then what does 12 and 8 have in common? Okay, what can I take out of both pieces? You want the greatest common factor, so you could take out a 2, but it wouldn't be enough. The highest number you could take out is a 4. So if you take out a negative 4, you're left with 3x plus 2. Okay, so if I were to multiply negative 4 in that set of parentheses, all right, I would get this same thing up here. Okay, and what's good is I see 3x plus 2 in both sets. All right, so I know that this is the correct set of factors. All right, so I'm going to go x minus 4, and then 3x plus 2. And do I see that written anywhere? All right, well, these are out. Okay, so I see a 3x plus 2 here, and then the x minus 4. Okay, and so what this is saying here is if I were to multiply this out, I would get that same expression at the top. Okay, and so what we found here, you know, it's kind of weird to think about, but this is like our length, and this is like our width. Okay, so when you multiply the length and the width, you get the area. All right, don't forget, it's the area of a rectangle. Okay, in this case, when we multiply this length, which is x minus 4, okay, with this width, which is 3x plus 2, okay, when you multiply these two numbers together, your length and your width, you'll get this same number or expression in this case as you would up here. Okay? So, the answer to number 19 is 1. All right, let's take a look at number 20, and we'll call it a day for day 4. Okay, so if c is equal to 2a squared minus 5 and d is equal to 3 minus a, then c minus 2d equals. All right? So it looks a little wild at first, okay? What it's really saying there is c is equal to this and d is equal to this. So by using substitution, all right, I'm going to switch around what this expression looks like. Okay, so you take a look at c. So we got c minus 2d. All right, so using substitution, okay, I substitute that in for c, then minus 2 times whatever d is, which is 3 minus a. Okay, and that's all it wants us to do here. It just wants us to use substitution and take this expression and substitute it in for a, and this expression and substitute it in for d. Okay, now once we are here, you're going to distribute. So you're going to have 2a squared minus 5 minus 6 plus 2a. All right, now if you notice, all of these expressions are written in standard form, so they're going to want us to do the same thing. So 2a squared, all right, I'm going to put the 2a behind the 2a squared, and then negative 5 minus 6 is negative 11. And do we see that up top there? We sure do. And that is number 3. Okay, so that is the answer key with answers, or with the video, right, so you guys can hear me. All right, video recording of day 4. Okay, so stay tuned. Day 5 is coming here in just a few moments. All right, hopefully you guys are watching these. Hopefully you find these useful. And like I said, email me, guys, anytime. Right, you need me to help you answer a question or point you in some sort of direction. Okay, as teachers, we've got extra time here, so make sure you're using us. All right, make us work a little bit. All right, email